Separation of water and oil when being mixed is considered as a spontaneous process. It occurs without apparent external cause. The oil floats naturally because it is less dense than water it was spilled into.
A spontaneous process is one that occurs on its own, without any energy input from the outside. For example, a ball will roll down an incline. No intervention is required because these processes are thermodynamically favorable. In other words, the initial energy is higher than the final energy.
Another example of spontaneous process is opening of the soda. According to the second law of thermodynamics, any spontaneous process increases the disorder of the universe. An example of a spontaneous reaction is aeration. Aeration occurs when a soda bottle is opened, since the carbonic acid spontaneously decomposes to carbon dioxide and water.
In our next example of spontaneous process, we will consider a hot pack cooling.
Now this is a warmed hot compress. In time, it will then begin to cool down on its own. This is then considered as a spontaneous process because heat flows voluntarily from a hotter to cooler one.
A flame on top of a matchstick is a spontaneous process because it is a combustion reaction and it continues on until one of the reactants is gone and the fire is eventually put out.
This procedure occurred without any intervention because the ice melts on its own in the juice. As a result, we consider melting of ice to a juice to be a spontaneous process.
Diffusion is presented as a process in which a substance moves down a concentration gradient from high to low concentration. For example, you're standing in a room and someone sprays some perfume or open a diffuser. Its scent molecules will move into the air as they interact with the air molecules. Over time, it will cause the scent molecules to disperse throughout the room. It is the spontaneous motion that leads to diffusion, which makes it a spontaneous process.
Another example can be seen when adding Mentos to Coke. A spontaneous process will occur even though there's a slight contributing factor in order to start the reaction. It is still considered spontaneous due to the fact of the releasing of energy with no continual input of outside force.
Burning candle illustrates an increase in entropy. It starts as a single solid object, then the fire consumes the candle wick, releasing energy along with carbon dioxide and leaving hot wax in a liquid state. Therefore, from solid state, the candle becomes liquid in the form of hot melted wax.
To begin, you must first apply activation energy to the receipt by lighting a match to it. The receipt would then spontaneously catch fire and burn. Chemical energy exists in the receipt is composed of paper. The potential energy of materials changes as they are burned. Some of the energy is converted to thermal energy before being released into the atmosphere. Thus, the amount of entropy in the universe is considered to have risen.
Entropy states that the universe tends toward the high state of disorder. An example of this is mixing food coloring with water. A food coloring mixed with water tends to produce entropy, since water molecules slowly mix with food color. This is to say that a food coloring with water has a higher entropy than a separated food coloring and water.
For entropy, let's consider the air leaking in a punctured tire.
In this case, energy tends to be dispersed through the tiny pierced hole. As energy tends to spread out if there is a chance, the reaction will cause a state of disorder. Therefore, this example is considered as high entropy.
Making popcorn is an example of increasing entropy because the heat energy disperses through the kernels, causing them to pop. So this has more entropy than this one.
When the water boils, the entropy change is fairly substantial because the molecules go from being somewhat restricted before the water is going to be boiled to be able to fly around when the water is being boiled.
Salt dissolves in water. Sodium and chloride ions are pulled apart to form new weak bonds with water molecules. The reason why it dissolves readily involves entropy, which is a measure of how energy is in the system. When it dissolves, the entropy of the water and salt ions increases. The increase in the entropy of the water and the salt is greater than the decrease in the entropy of the surroundings. So, the overall change in entropy is positive. Hence, the salt dissolves.
Melting ice makes a perfect example of entropy. As ice melts, the molecules become free to move, therefore becoming disordered. As the water is then heated to become gas, the molecules are then free to move independently through space.